Hello and welcome to one and all. I am Miss Premal Popat and today we are going to start with the third module of the chapter Heat from the 10th Standard Science and Technology Part 1 textbook. And in this module 3, we are going to study about the regulation, dew point and humidity. So let's proceed with the topic. For the preparation of an ice ball, what are the steps needed? What is the actually process of preparing an ice ball? Let us see that now. First, an ice slab is taken and then it is shredded with the help of a machine. So we get finely shredded pieces of the ice slab. And then this shredded ice is pressurized around the tip of a stick to prepare the ice ball. So basically over here we can see a stick. Okay, this is a stick and around this stick the ice, shredded ice, is pressurized. We have seen this, right? But how does the shredded ice convert into a solid ice ball? Have we ever wondered that why this shredded ice is converted into a solid ice ball? First it was a solid ice slab, then it was finely shredded small pieces, and then again we got a solid ice ball. So basically, why does this thing happen? Let us understand now. Now let us understand an activity. In the picture we can see an ice slab over here placed on a table, and there is a wire above the ice slab, and the two ends of the wire are connected with weights. Okay. So put a slab of ice on a stand as shown in the figure. The second step is hang two equal weights to the two ends of a metal wire. So basically this is which wire? A metal wire, and weights are hanged. Okay, and put the wire on the slab as shown in the figure. So what do we observe from this arrangement? The observations from the activity are: it is observed that the wire gradually penetrates and passes through the ice slab. Now in the picture which is displayed on the screen, we can see that the metal wire has penetrated in the glass slab. Okay, and then slowly it passes through the glass slab. But why does this happen? This happens due to the fact that the ice melts at a lower temperature due to the increase in pressure just below the wire. So these weights are connected to the two ends of the metal wire. Why the weights are connected? So that there will be pressure exerted on the metal wire in the downward direction, and when the pressure is exerted, the ice melts at the lower temperature. So over here, as the metal wire is penetrating, the ice melts at a lower temperature due to the increase in pressure just below the wire, and due to the melting of the ice, the metal wire slips inside the ice slab. When the wire has crossed, water above the wire solidifies. See, now when the wire is crossing, so just below the metal wire the ice slab has melted, and that is why it is going inside. So when it is crossed that position, now the water above the metal wire which was first melted, now it will solidify. Okay, and hence the wire passes through the slab without splitting it, and that is why the metal wire is able to penetrate through the glass slab completely without breaking the glass slab. Why? Because first the water is first the ice slab is melting, and then the wire is pushed down, and the water above the metal wire the water above the metal wire solidifies. It changes its phase into the solid form, and that is why the ice slab doesn't split and the metal wire can pass easily. This phenomena of refreezing is known as regelation. So this phenomena of the water solidifying is known as regelation. Here the melting point of the ice becomes lower than 0 degrees centigrade due to the above applied pressure. So the melting point of the ice becomes lower than 0 degree Celsius due to the pressure applied on the ice slab. This implies that at 0 degree Celsius, ice is converted into water, and as soon as the pressure is removed, the melting point is restored back to 0 degrees Celsius. Now what happens over here? So what happens is, at 0 degrees Celsius, ice is converted into water, okay, when the pressure is applied. Now as soon as the pressure is removed, the melting point is restored back. First the pressure is applied, then at 0 degrees Celsius the ice is melted, and when the pressure is removed, the ice is again solidified, okay, and the melting point is restored to 0 degrees Celsius and the water is converted to ice again. So this phenomena is known as regelation. Now let us define regelation. Regelation is defined as the phenomena in which the ice melts to water below 0 degrees Celsius. Now due to the pressure applied in the previous activity or the experiment, we can say, due to the pressure applied, the melting point was decreased below 0 degrees Celsius, and that is why the ice melts to water on the application of pressure. It is because of the pressure. So pressure is applied, the melting point of the ice is decreased below 0 degrees Celsius and the ice is converted to water. And when the pressure is removed, it refreezes back to ice on the removal of pressure. So this process of ice melting to water and again refreezing back to ice is known as regelation. So what are the examples? If two small pieces of ice are taken and pressed against each other for a while, they stick to each other. In the picture we can see that two slabs of ice, this is slab 1 and this is slab 2. So these two slabs are taken and the pressure is applied from side. Here we can see the pressure or the force is applied from side of these two slabs, and same thing happens. First the ice is melted and then it is solidified again, and that is why they stick to each other. Like in the previous experiment also, or in the previous preparation of ice ball, same process takes place. That means the regelation is applied there also, and that is why we get a solid ice ball. The second example of regelation is, it is due to regelation that skating is possible on snow due to the formation of water. So basically what happens is, water is formed on the surface of the ice, and due to this skating is possible. Water is formed due to increase of pressure and it serves as a lubricant. So when the people skates on the ice, due to the pressure water is formed, and that is why skatings become possible, because it serves as a lubricant. Moving on to the second part of the module 3, which is humidity. We know that, and from the picture it is seen that almost 71% of the earth's surface is covered with water and 29% is covered with land. Okay. So we have so much of water on the surface of the earth. So what happens to this water? Constantly evaporation takes place. As we in the picture we can see that the water is evaporated and it gives rise to water vapor. What do we understand by this water vapor? Water vapor is water in the gaseous form. So constantly, continuously this water is evaporated and water vapor rises above high in the sky. So what we can say from this, that water vapor is present, always present in the atmosphere. This water vapor is the water in the gaseous form. And the amount of water vapor in the atmosphere helps us to understand the state of daily weather. Because of the amount of water vapor in the atmosphere, we know that will it rain or no. We know the daily report of the weather. Now the presence of water vapor in the air makes it moist. Moist meaning it becomes slightly wet. The atmosphere becomes slightly wet due to the presence of water vapor in the air. And the moisture in the atmosphere is called the humidity. So this moisture which makes the atmosphere slightly wet is known as the humidity. In the picture we can see that due to the more content of the water vapor, this water vapor has been turned into water droplets. So this moisture in the atmosphere, the wetness, the feeling of wetness in the atmosphere is known as the humidity. If there is a lot of water vapor in the air, the humidity will be high, as we can see in the picture, and higher the humidity, the wetter it feels outside. Okay, so more amount of water vapor in the air, more will be the moisture, hence more will be the humidity. And higher the humidity, better it feels outside, and that is why this water vapor turns into water droplets. Now the third part of this module, that is the dew point. We will study about dew point. So for a given volume of air at a specific temperature, there is a limit on how much water vapor the air can contain. Now we have, suppose in a box we have a particular volume of air and at a specific temperature. Now there is a limit on how much water vapor the air can contain. So there is a limit on the water vapor, how much it can contain, how much the air at a specific temperature can contain the water vapor. Okay. If the amount exceeds the limit, the excess water vapor converts into the water droplets. So if the amount of water vapor increases at a specific temperature, then the excess water vapor converts into water droplets. As we can see in the picture, the water vapor has been converted into water droplets. Now when the air contains maximum possible water vapor, it is said to be saturated with vapor at that temperature. So for a specific temperature, if the air contains maximum possible water vapor, like too much of water vapor, too much in excess of water vapor, then we say that it has been saturated with vapor. It can't contain more water vapor at that temperature. Now the amount of vapor needed to saturate the air depends on the temperature of the air. As we can see in the first picture here, at a specific temperature the air can contain specific amount of water vapor. So in the same way, the amount of water vapor needed to saturate the air, the amount of water vapor needed to saturate the air depends on the temperature. Okay, the first factor, amount of water vapor needed to saturate the air, depends on the temperature of the air. So if air temperature is low, it will need less vapor to saturate the air, right? It is but obvious. Temperature is low, So less vapor is needed to saturate the air. And if the temperature is more, if the vapor contained in air is less than the maximum limit, then the air is said to be unsaturated. Now at a given temperature, at a particular given temperature, if the water vapor contained in that volume is less, then the air is said to be unsaturated. If the amount of vapor exceeds its limit, the additional vapor will condense. So if the amount of vapor exceeds, the additional water vapor will get condensed into water droplets. So what do we understand by this dew point? This dew point is nothing but, suppose unsaturated air at a certain temperature is taken. So at a certain temperature we have unsaturated air and its temperature is decreased. At a certain temperature we have unsaturated air and the temperature of this air is decreased. What will happen? A temperature is reached at which the air becomes saturated with vapor. As we keep on decreasing this temperature, so at some point, at some temperature, this unsaturated air will become saturated. Why? Because the temperature is decreasing. And this temperature is called the dew point or dew point temperature. Okay. Now this temperature at which the unsaturated air becomes saturated is known as dew point or the dew point temperature. Now dew point is an absolute measure of how much moisture is in the air. So more the moisture in the air, more is the dew point. Okay. Absolute humidity. The vapor content in the air is measured using a physical quantity called the absolute humidity. So this absolute humidity measures the amount of water vapor in the air. And how do we define it? The mass of vapor present in a unit volume of air is called absolute humidity. The mass, the amount of vapor present in a unit volume of air is called absolute humidity and it is measured in kilograms upon meter cube. The units of absolute humidity are kg per meter cube. What is relative humidity? The feeling of humid or dry nature of air, the amount, that is the amount of moisture present in the air, depends on two factors. And what are they? The amount of vapor in the air and the temperature of the air. We know that at a particular temperature, particular amount of water vapor can be present, right? So this feeling of humid or dry nature of air depends on amount of water vapor and the temperature of the air. So how do we define relative humidity? The ratio of actual mass of water vapor content in the air. It is the ratio of what? In the numerator we have mass of water vapor content in the air for a given volume and the temperature to that required to make the air saturated. So in the denominator we have the temperature required to make the air saturated with vapor. So it is the ratio of actual mass of water vapor for a given volume and the temperature required to make the air saturated. And this is known as relative humidity. How do we calculate percentage relative humidity? In the same way, actual mass of water vapor content in the air in a given volume upon mass of vapor needed to make the air saturated in that volume. And we have to multiply this by 100. Why? Because we are calculating percentage relative humidity. So this is the difference between absolute and relative humidity. What we can say from this picture, this is relative humidity versus dew point. So the relative humidity at the dew point, when the air temperature and dew point are same, it is 100%. Okay. And when the relative humidity is more than 60%, what we can say? The air is humid. When the relative humidity is more than 60%, we say that the air is humid. Humid in the sense moisture is there in the air. Now if the relative humidity is less than 60%, we say that air is dry. So in the picture here, the temperature of the air in the second part is shown in yellow color, and the third part it is orange color. That means in the second part it is humid, there is moisture in the air, and in the third part the air is dry, the humidity has decreased. Okay. Now there is a small activity for you all. Take a bottle of cold water out of the refrigerator and keep it outside for a while, and observe the outer surface of the bottle. So when we do this, what happens? We see there are droplets formed on the surface of the water, as we can see in the picture. On the surface there are water droplets formed. Okay. And in the second picture we can also see during the morning time there is water on the surface of the leaves. Yes, but why does this happen? So drops of water can be observed on the outer surface of the water, and in the same way, if we observe the leaves of plants or grass, or a window glass of a vehicle, in the early morning we see water droplets collected on the surface. But why does this happen? We sense the presence of water vapor in the atmosphere. Now these droplets are formed. These droplets are nothing but the water vapor in the liquid form, right? Due to the excess amount of water vapor at a given temperature, it has been converted into liquid form. So we sense that there is water vapor in the atmosphere. So when air cools due to decrease in the temperature, it becomes saturated. Now I have removed the bottle from the fridge and I have kept it outside. Outside the temperature is according to the room temperature, right? So the air besides this bottle, now the air besides the bottle, it is at room temperature, but due to this freezed bottle, the air besides the bottle will cool down, right? And also due to this decrease in temperature, so basically its temperature is decreasing. Now when the temperature decreases, when the temperature of the air besides the bottle decreases, it becomes saturated with vapor. And due to this, when it becomes saturated with vapor, the excess water vapor gets converted into tiny droplets. So due to this saturation point, the excess water vapor gets converted into the tiny droplets, and we can see droplets all over the surface of the water bottle, right? And the dew point temperature is decided by the amount of water vapor in the air, right? Also, we know that in the previous slides we have studied that the dew point temperature is the amount of water vapor in the air. That means at what temperature the air gets, or the water vapor gets saturated. Now in the same way it happens for the leaf also. In the morning, the air besides the object gets saturated and the excess water vapor is converted into tiny droplets. Now what are the units of heat? The units of heat are joule, represented by J in SI system, standard system, and calorie, we can write it as cal, CAL, in CGS system. So how do we define 1 calorie? 1 calorie is defined as the amount of energy needed. It is the amount of energy needed to raise 1 gram of water by 1 degree Celsius. So 1 calorie is defined as amount of energy needed to raise the temperature by 1 degree Celsius, and temperature of whom? 1 gram of water. Now I want to represent this 1 calorie in terms of kilocalorie. So 1 kg of water, that is 1000 grams of water, would take how many calories? 1000 calories. Why it would take 1000 calories? Because 1 calorie is taking 1 gram. So but natural 1000 gram, it will take 1000 calories. So how we define 1 kilocalorie? 1 kilocalorie is 1000 calories. So these are the units of heat. Okay students, now in this module 3 we studied the regelation, humidity and dew point, and we'll be continuing with this chapter in the next module. Thank you students for your attention.